Okay, now we'll look at two examples where we're finding the sine and cosine using the unit circle, but for angles that aren't necessarily on there. And so we have sine of 5 pi over 12. It's not on the unit circle, but what we're hoping here is that we're going to be able to write this as the sum of two angles that are. And so the way I think about doing this is I need to write 5 pi over 12 equal to the sum of two things. And I'm going to start out with them being over 12. And I know there's going to be a pi at each one. So something pi over 12. And so the question is, what can I use? And there are a lot of answers, right? I could use 1 and 4. But I'm going to use 2 and 3, and we'll see why maybe, hopefully. So why is this good? Because 2 pi over 12 will simplify to pi over 6, and 3 pi over 12 will simplify to pi over 4. And these are angles that are on the unit circle. So if I had used pi over 12 and 4 pi over 12, well, this one will simplify to pi over 3, so that's nice. But then this one doesn't simplify at all, so this, even though it does give me 5 pi over 12, isn't a good thing to use for this sum formula. Okay, so these are the angles I'm going to put in here. So 5 pi over 12 is the same as pi over 6 plus pi over 4. So let's go back to our sum formula. Down here, this is sum for sine, so it's going to be sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Okay, and so let's put these in. This is pi over 6, pi over 4, pi over 6, pi over 4. Okay, so sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2, and sine is square root of 2. Sine of pi over 4 is square root of 2 over 2. So this is the square root of 2 over 4 plus the square root of 6 over 4. And so the best we can do, I guess, is write this as a single fraction.